Okay, guys, you need to have your Chromebook out and you need to have your notebook. Today we're going to do dilating plane figures. So go ahead and open up that assignment, dilating plane figures. And we're going to do the step-by-step examples. So we're going to take notes just like we did on our other transformations. Move this over a hair. Okay. I am going to write the title of this lesson, which is dilating plane figures. And then I'm going to copy this area here. Select the transformation needed to match the shaded pre-image to the dashed image. You can use only one transformation. I'm going to shade my pre-image blue and my image target dashed black and white. So just like we did on translations, reflections, and rotations. So I'm going to come over here. I'm going to come to the top of my page. I'm going to type it out. It's going to be easier for you to read it if I type it. You guys are writing it. So I'm going to type out dilating plane figures. So this is my title. And then I'm going to type out the problem. So select the transformation needed to match the shaded pre-image to the dashed image. You can use only one transformation. Okay, I'm going to move this down a hair. And then I am going to put it in a box in just a minute. So I'm going to put pre-image, image, target. Okay, then I'm going to put my boxes here. Let's see, I'm going to try to turn it black. Okay, well, we'll just keep it blue. Okay. Now I'm going to draw, and I'm going to come over here and I'm going to shade my box into blue. And then I'm going to change this to black. Oh, erase that. Let's try this again, black. There we go. Okay. If you need to pause the video, go ahead and pause the video so that they have this all copied. Make sure you walk around and make sure that they have it copied. Okay, once you have gotten this copied, we're going to make our coordinate plane. So I'm going to come over here and I'm going to draw my coordinate plane, and I am going to start it at 11, and I'm going to go down to 5. And I'm going to keep it all on in quadrant 1 and use only positives. So if I look, I need it to go to 10, so I'm going to go to 11. And then I need it to go to 6, so I'm going to go to 5. And I don't need any of this on the negative side because everything's positive. So I'm not going to use this big area. We're going to make ours smaller. So it's going to go 11, 10, 9, 8, 7, 6, 5. So I'm going to draw my line here. And this is my y-axis. And this was 11, 10, 9, 8, 7, 6, 5, and then I'm going to come across here, and I need, let's see, what do we need? We need 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to go to 9, so I'm going to go to 10. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so go ahead and copy your coordinate plane. Our y values are going to be 11 down to 5. And then our x values are going to be 1 all the way to 10. And then I'm going to graph my pre-image first. I'm going to graph my pre-image first. So if I go back, my pre-image, I'm going to go E, F, G. So point E is at 3, 6. So I'm going to come over here and I'm going to go to 3, 6, and I'm going to put a dot. I'm going to change this and make it larger, and it's blue. So 3, 6. So that's my first point. F is at 5, 10. I'm going to go over 5 and up 10. And then I'm going to write the letters for the points in just a second. And then G is at 9, 6. I'm going to go over 9, I'm going to go up 6. Okay, I'm going to change my writing to 1, and I think it was E, F, yeah, E, F, G. So this is point E, F, and G. I'm then going to connect my points. So I'm going to go F to E. I'm going to go E to G, and then F to G. I'm actually going to redo that one. Okay, and then I'm going to color in my triangle. Because it's supposed to be a solid. Okay, so that's my pre-image. Then I need to do my image. Again, please pause the video, walk around and make sure students are drawing this, give them time to get caught up, and then hit play again. Okay, our next one is our image. So E is going to be the same. F is at 4, 8. So I'm going to go over 4 and up 8. And then that's F prime. G prime is at 6, 6. So 6, 6. And then I am going to connect. Oops, I can't see that one to see where I. Okay, let's try this again. Let's have that one, and I have that one. I'm gonna write E, oops, I'm gonna change the color. E prime, F prime, and G prime. And then we're going to stripe this one. So that way I know what my image is and what my pre-image is. Okay, now I have to decide what I'm gonna do. So again, go ahead and pause the video. Make sure everyone has the figure drawn. And then we'll hit play when we're ready. Okay, I know that this is my pre-image. I know the blue one's my pre-image because they told me. My pre-image is larger than my image. That means I'm going large to small. That's going to be important. So I'm going to come over here. I know that this is a dilation because my title is dilation. So I'm going to hit dilation. It says dilate about the point E by a factor of. So I have to decide, is it a factor of 1/4, a factor of 1/2, a factor of 2, a factor of 4? So in order to do that, I'm going to come back to my grid and I'm going to count. So I know from my large one is 1, 2, 3, 4, 5, 6. So I know that FG, EFG, triangle EFG is 6. And actually, it's not going to be triangle. It's that side. So it's side. So side EG is 6. And then if I look at my smaller side, EG, E prime, G prime, I'm going to erase these. And now I'm going to do it again, but I'm going to do just my E prime to G prime. It's 1, 2, 3. So I know that side E prime to G prime is 3. So I know it's 3 over 6. I always put my image over pre-image. So that's why I did E prime, side E prime G prime over side E G prime. Now I can simplify this. I can put 3/3 into 3/6. 3 divided by 3 is 1, 6 divided by 3 is 2. So I know this is dilated by a scale factor of 1/2. So now I'm going to come back here and I'm going to select 1/2 and hit transform. Does the transformed pre-image match the image target? So once we did it match it? So I'm going to hit dilation, let's see. And the answer is going to be yes. So we're going to come over here and we're going to type that, or you're going to write that. I'm going to type it so you can see what I'm writing. So on your paper, put, does the transformed pre-image match the image target? And just like reflections, rotations, and translations, we said yes. Okay, then we're going to look at our next thing. So hit yes. Now it says select the statement that best describes the original pre-image and target image. So remember, when we did reflections, rotations, and translations, we said they're the same size and same shape. Are these the same size? So look at my blue and look at my gray here. Are they the same size? No, they're not. Are they the same shape? They are the same shape. So we're going to say they're different sizes, but same shape. So we're going to come back over here and we're going to put sorry, my computer's acting up. They're different sizes, but the same shape. So, oops. What the heck is going on? They are different sizes, but the same shape. Be careful. We're used to hitting same size, same shape, same size, same shape, because that's what we put for our last three that we did because they were rigid motions. This is not a rigid motion because they're different sizes. Okay, so now we're going to look at the next thing. It says, select the conclusion that follows from the previous statement. Last time we hit they're congruent and similar. Remember, congruent means same size, same shape. Are they same size, same shape? They're not. So it's not going to be that they're congruent. The next one says the figures are congruent but not similar. That's not right because we know it's not congruent. The figures are similar but not congruent. So are my figures similar? Yes, they're the same shape, but they're not the same size. So we say the figures are similar but not congruent. This is always going to be true about your dilation. So now we're going to come down here and we're going to hit the figures are similar but not congruent. Okay, this box right here that we just did is going to be important because it's always going to be yes, they're different sizes but the same shape, and the figures are similar but not congruent. And be careful because you don't want to hit what we've been hitting for the last lessons. Okay, you're going to use these notes now to do a couple problems. So I want to do one with you. Yours is not going to be the same as mine because I want to make sure that we understand what we're doing. Okay, so again, my pre-image is my blue and my target image is my striped. So I know it's a dilation. I have to decide how I am moving this. So my pre-image is 1, 2, 3. My image is 1.5. It's not quite all the way over there. Okay, so I'm going to come over here and I'm going to write it down here. You don't have to put this in your notes, but I'm going to put it so you can see how to solve this. So remember, it's always image over pre-image. So I'm going to come back. My image is the black and white. So I'm going to do this piece right here, this TS, it's 1.5. And I know 1.5 is 1.5. So I just counted my boxes, this whole box and a half a box. My pre-image is this whole thing here. So it's 1, 2, 3. So it's over 3. Okay, well, I know that half of 3 is 1.5. So I can divide both sides by 1.5. 1.5 divided by 1.5 is 1. 3 divided by 1.5 is 2. And you can use your calculator on your Chromebook. So I know that this is a dilation of 1/2. So I'm going to hit transform. Does the transform pre-image match the target image? Yes, it does. They are not the same size and same shape. They're different sizes, but the same shape. They're not congruent. They're similar, but not congruent. And then I'm going to go to the next one. Okay, so you're going to pick one side. You don't want to use a diagonal side. You want to do a straight side. So I would do AB and then do A, or do A prime, B prime, and then do A and B. So this one is 1, 2, 3. So that means it would be 3 on top. And then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 3 over 12. 3 can go into both of these numbers. 3 divided by 3 is 1. 12 divided by 3 is 4. So that means that this is a dilation of 1/4. Okay, this is going to be yes. This is going to be, they are different sizes, same shape. They are similar but not congruent. I want to try to get to a whole one the opposite way. Okay, so this one is actually smaller and then it goes big. So again, I'm going to use my prime. So I'm going to pick CA and CA, or C prime, A prime, and CA. So I'm going to go 1, 2, 3, 4, 5, 6. So I have 6 over, and then I'm going to go 1, 2, 3. So 6 over 3. Well, I know that I can divide both of these by 3, and I end up with 2 over 1, or 2. So this one's not a fraction. This one's dilated by a whole number, and it's because it was big. Sorry, it was small and it went big. So the answer is yes. And then they're different sizes but same shape. Figures are similar but not congruent. So it shouldn't take you very long. It looks like there's 3 problems if you don't mess it up. So if your problems are your pre-image is small and then it goes big, sorry, I'm working on 2 computers here. So if your pre-image is small and then it goes big, you'll have a whole number. If it's big and it goes small, you'll have a fraction. Okay, so go ahead and get it finished so that you don't have any homework. And I will see you guys on Thursday.